Welcome, everyone, to the Deep Dive here on the F1 Blogs channel.
Great to be here.
Today, we're really firing on all cylinders, you could say. We're dissecting a really interesting development in Formula One, McLaren's apparent mastery of rear tire temperature management. We're talking about their 2025 car.
Yeah, it's been a hot topic, no pun intended.
Exactly. So if you're keen to understand what might be giving them this, well, pretty crucial edge, consider this your fast track.
Definitely. And we'll be digging into insights from a really detailed discussion, actually. It's from the F1 Blogs channel, analyzing McLaren's clever F1 brake trick.
Right. So our mission today is basically to unpack the possible reasons behind McLaren's, let's say, superior performance in this area. We'll focus mainly on the braking system.
And this is important, keeping in mind that it's probably part of a bigger picture, right? A whole integrated solution.
Absolutely. Okay, let's dive right in. The million-dollar question, the one that's got everyone in the paddock buzzing, is what is the secret? How are McLaren keeping those rear tires so cool?
Yeah, and I think the consensus is building that we're probably not looking at one single silver bullet here.
No magic wand.
Exactly. It's more likely a symphony of clever engineering. Lots of things working together.
Okay, so one area that's really grabbed attention, especially rival teams,
Oh, definitely.
is McLaren's brake system. This whole thing seemed to kick off after Red Bull reportedly got some thermal images, right, at the Japanese Grand Prix.
That's the story, yeah, during pit stops. And these images supposedly showed McLaren's rear brake drums running significantly cooler than their competitors.
And, well, predictably, that just sparked a huge wave of theories, didn't it?
Oh, absolutely. People were guessing everything. You had, like, unique carbon fiber weaves for better cooling.
Right.
Exotic phase-changing materials, which sounds very sci-fi.
Yeah.
Even some pretty wild accusations of illegal vapor blowing inside the drums.
Which, as the F1 Blogs analysis pointed out, would be totally illegal. Liquid cooling of brakes is just not allowed.
Correct. Forbidden. And there were also those sort of unsubstantiated rumors flying around about the FIA maybe impounding McLaren parts earlier in the season.
Yes, trying to explain their strong start in Bahrain and Saudi.
Exactly. But look, a lot of that speculation was pretty firmly put to bed after the Miami Grand Prix.
Miami. Yeah, that was a real statement piece from them, wasn't it?
Totally. Despite those boiling hot conditions, McLaren just dominated. Piastri's win, I mean, the gap back to the non-McLaren cars was huge.
It really showed their performance wasn't just a flash in the pan.
And crucially, the FIA did their checks. Thorough inspections of the braking system right through Sunday evening in Miami.
And the verdict.
Unequivocal. McLaren's system is completely legal, just, well, clever design. Ingenious, really.
Yeah, okay. So it's legal, it's clever. Before we unpack McLaren's specific solution, maybe we should quickly cover the basics. You know, how F1 brake systems generally work.
Good idea. Yeah, set the baseline. So externally, when you see a car with the wheels off, the brake drums often look pretty similar.
Right, the rules dictate a lot of that.
Exactly. The size, the shape. These drums are basically carbon fiber covers, shielding the important bits inside. The discs, pads, calipers.
So the real secret sauce, the stuff where teams can innovate, that's all hidden under the drum.
Precisely. That's where they devise their own strategies for dealing with all that heat from braking, and crucially, how it affects the tires.
And it's a massive amount of heat we're talking
Yeah,
about.
huge. Teams are constantly walking this thermal tightrope. They need the carbon brakes hot enough to work optimally. They don't work while cold. But at the same time, they have to get rid of the immense heat generated by friction, hundreds of degrees Celsius, almost instantly.
Wow. And if you don't manage that heat properly, it just radiates out, right?
Yes.
Heats up the drum, the wheel rim.
And bingo, your tires start overheating, which is exactly what you don't want, especially at the rear.
So how do teams typically try to manage this?
Well, many use something called a double basket arrangement. The F1 Blogs analysis used Red Bull as an example. It involves an inner basket, kind of designed to channel the hot air away from the back of the drum. The idea is to create an insulating gap, like a pocket of cooler air, between this inner basket and the outer drum.
So minimizing heat transfer to that outer surface and then onto the tire.
Exactly. So the big challenge for these teams is getting enough airflow to cool the brakes themselves, but also maintaining that insulating layer of cooler air to shield the tires.
It's a balancing act.
Absolutely. Alpine's technical director, David Sanchez, put it quite well. He said the ideal is using the minimum airflow you need for the brakes and maximizing the rest for cooling everything else.
Makes sense. Is the approach different for front and rear brakes?
Yeah, generally. At the rear, the absolute priority is stopping heat reaching the tires. Keep them cool.
Right.
At the front, though, sometimes teams actually want a bit of heat transfer. It can help get the front tires up to temperature faster, which is good for grip, especially in qualifying.
Interesting distinction. Okay, let's zero in on McLaren now.
Yeah.
The F1 blog's analysis suggests their rear solution is, well, particularly clever. What makes it stand out?
Well, while some teams might leave bits of the disc or caliper slightly exposed to help with cooling, McLaren seems to have gone the other way.
How so?
They appear to have gone for a very, very tight enclosure around these hot components, probably using ceramic-lined carbon fiber for extra insulation.
So they're really boxing everything in.
Yeah, which shows a lot of confidence, actually. It suggests they feel they have really precise control over the temperatures inside that enclosure.
And how are they achieving that control? It sounds like some very complex airflow management inside. The F1 blog's video describes some intricate pathways.
Yeah, based on those descriptions, it sounds incredibly detailed. There's apparently a yellow flow path going to the inner side of the brake disc, maybe cooling a sensor there.
Okay.
Then a light blue channel supplying air down to the low-slung caliper. Above that, a dark blue duct seems to feed the outer face of the disc.
But the really smart bit seems to be this green channel they mentioned.
That's what it sounds like, yeah. A separate stream of cooler air that essentially wraps around everything else inside, like a thermal blanket made of air.
An insulating layer.
Exactly. And the F1 blog's analysis noted that the intake vent for this particular cool air channel looks bigger on this year's McLaren compared to last year's car.
Ah, so they've maybe enhanced this insulating effect?
It seems plausible. This circulating layer of cooler air would be really effective at stopping heat conducting from the hot brakes out to the wheel rim.
And you mentioned earlier, it's not just about getting cool air in, getting the hot air out is just as vital.
Absolutely critical. You need effective exit ducts. McLaren seems to have put a lot of effort here too, with bespoke channels that look different from their rivals.
Why is the exit so important?
Because effective cooling relies on creating a low-pressure area at the exit. That low pressure literally pulls the cooling air through the whole system. It's not just passive flow.
Got it. The F1 blogs piece also picked up on something else, a mysterious sensor, purple, with a silicon pipe attached.
Yes, that one was intriguing. Its exact job isn't confirmed, obviously, but the best guess is it's probably a pressure or flow sensor.
Measuring what?
Likely monitoring the airflow in that outer insulating layer we just talked about. Checking that the temperatures are being managed, that the pressure is right, ensuring hot air is actually getting pulled out efficiently.
And they only use this during practice, apparently. Then they tape over the hole for quali in the race.
That's right. It comes down to error rigs again. During practice, teams have a bit more freedom. But for qualifying and the race, the rules demand a completely sealed, unbroken aerodynamic surface around the whole brake drum. No holes allowed.
Wow, the level of detail is just astonishing. You know, the analysis also made an interesting connection between McLaren's current success and their past struggles. Remember Bahrain 2022, those brake problems?
Oh, vividly. Yes, back then they had a real issue with pressure imbalance in their brake design. Well, the airflow didn't go where it was supposed, though. Sometimes it even reversed, pulling hot air back towards the disc, causing massive overheating. The technical director at the time admitted they'd, quote, messed up the initial design.
So the pain of 2022, figuring that out, might have actually given them a deeper understanding now, leading to this clever solution.
It certainly seems plausible. You know, necessity is the mother of invention. Overcoming those challenges probably taught them a huge amount about the really fine details of thermal dynamics inside these drums.
Right, and now, with the FIA confirming it's all legal and seeing that dominant Miami performance, it really suggests McLaren's potential has been building thanks to this kind of progress.
Definitely. Although it's important to remember what the team principal, Andre Steller, said after Miami. He really emphasized improved tire management overall as a key goal for this MCL39 car.
Which brings us to a really crucial point. The brakes seem like a big part of the puzzle, but probably not the whole puzzle, right?
Exactly. It's unlikely to be the sole reason for their great rear tire temp management. There are almost certainly other factors contributing.
Like what? What else could be playing a part?
Well, one possibility that gets discussed is maybe they're using slightly more electrical energy recovery regen from the rear axle under braking.
Using the MGUK more.
Potentially. If the electric motor does more of the slowing down, the physical friction brakes don't have to work quite as hard. Less friction, less heat generated in the first place.
That makes perfect sense. Less heat to manage from the start. And the F1 blogs analysis also mentioned the car's mechanical setup.
Yes, things like their suspension geometry, high percentages of anti-dive and anti-lift, the way the lateral suspension works.
How does that help tires?
It helps keep the tire's contact patch more consistent on the road, especially under braking and acceleration. A stable contact patch generally means less sliding, better grip, and therefore less heat buildup in the tire itself.
And controlling the car's center of gravity height.
That helps too. It reduces how much the rear tires unload or lift during heavy braking. Again, keeping things more stable, managing temperatures better. It really seems like a holistic approach.
Yeah, all these different elements working together.
Precisely. It's like a snowball effect,
Yeah.
or maybe a virtuous cycle. You've got this really detailed brake cooling plus smart mechanical choices,
Which means less heat goes into the tires,
leading to a more stable rear end, allowing the tires to run cooler.
which gives them a decisive advantage, especially in hot conditions with heavy braking zones like we saw in Miami.
Exactly that. It all adds up.
Okay, so pulling it all together then,
Yeah.
it looks like McLaren's advantage with rear tire temps isn't one magic trick. It's more like a combination of a really intricate but crucially legal brake system, working hand in glove with clever mechanical design and maybe some smart energy recovery strategies too.
That sums it up pretty well, I think. This deep dive, drawing on that F1 blogs analysis, really just underscores the incredible complexity, the sheer ingenuity in modern F1 cars.
Yeah, how these tiny looking details can add up to huge performance gains.
Absolutely.
Which leads us to a final thought for you, our listeners. Now that the FIA has given McLaren's system the green light, what do you think the other teams will focus on? Will they try to copy it or find their own path?
And how long might that take, given the complexity we've just discussed?
Right. It also makes you wonder, doesn't it? What other tiny, seemingly insignificant details on these cars might be hiding the next big performance secret?
Always something new to uncover in F1.
Indeed. Well, thanks for joining us for this deep dive here on the F1 Blogs channel.
Pleasure as always.
And a final word from us and from F1 Blogs. If you enjoyed this analysis, make sure you head over to the main F1 Blogs YouTube channel and hit that subscribe button for more F1 insights.